Okay, I'm showing you 3 examples to show horizontal area. Okay, so if you look at this question, the first part asks you for the coordinate of A and B. Okay, this one, I'm going to leave it to you to find yourself. So to find A and B, that will be quite easy because they are on the y-axis. So in a way, they are y-intercept. So if you put x equal to 0, you should be able to get 2 answers. So the 2 answers that you have gotten should be these 2. And you should be able to tell which is which. So this one will be a 0, 4. And then this one will be a 0, -2. So A will be a 0, 4. B will be a 0, -2. So in this case, I don't need to do simultaneous. It's a y-intercept concept. So I'll be using these 2 y coordinate for the area on the graph. Okay, now in this case, right, you realize the area is on the left side. The area is on the left side of the y-axis. So I'm expecting this area to be negative. So you have some expectation first. Okay, and I'm going to integrate. I'm going to integrate using the y coordinate. So the y coordinate will be 4 - 2. So I'm using the y coordinate, so it will be dy. So I will have this part that I got to manipulate. So I got to make x the subject. So I got to make x a subject. Yeah, I prefer to expand out everything. So I prefer to expand out everything so that later on my integration is a bit easier. So I'm going to manipulate the equation until x is my subject and everything else is in terms of y. So I'm going to put the equation here. So if you are doing an integration with dy, the whole expression here has to be in terms of y. If you are doing an integration with dx, then the expression will be in terms of x. Okay, so this is the part that a lot of students might forget. They might forget to manipulate the equation. So after this, you do your normal definite integral. Okay, I will not show you. Okay, you do your definite integral. Okay, we don't forget, we are expecting to get negative answer. So if you take a look, right, top minus bottom, you are actually getting a negative answer. So to counter the negative, I'm going to put a negative outside. So I'm going to put a negative. So eventually I'll get a positive answer. Okay. So if you forget that it is a negative area, it's not an issue. If eventually you got, how come my area is negative? Then you can trace back the steps and then put in the negative. It's fine. So maybe you forgot, then suddenly when you realize that your shaded area is negative, then you go back to the working and put the negative to counter the negative area, to counter the negative definite integral. Okay, so this is an example where the area under graph is on the left side, that's why it's negative. And you got to make x the subject for the equation in order to integrate. For this one, the next one, if you look at the shaded area, it falls under the idea where the shaded area is floating in the air. Okay, so the question says that the graph intersect at these 2 points. They never ask you to find the coordinate of P and Q. They just ask you to find the equation, the area of the shaded region. So do you still need? Yes, you still need the coordinate. So in order to get the coordinate, you got to do your simultaneous equation. which I will not be showing you. So you do your simultaneous equation, eventually you will get coordinate. So the coordinate I got will be 5, 4, and 2 minus 2. So this one fall under the situation where you're going to subtract the area. So I'm going to teach you how to subtract the area. So you cross over the intersection. So remember, you dot over the intersection. So this will be 4. So you dot over with the y coordinate. So if I want the shaded area, I'm going to do the trapezium first. I'm going to do the trapezium. So I'm going to do the trapezium first. Like I mentioned, you can integrate the straight line. So you can integrate the straight line. For the trapezium, right, you got 2 choices. So you must remember to manipulate the equation. So for the trapezium, you can either integrate this, or I'm going to do a half sum height, sum of parallel length. So where is the height? This part is the height. Where is the parallel length? The parallel length are here. And how are you going to tell the parallel length? You tell by the x coordinate. So that will be 5 plus 2. So either way, you will get the correct answer. So you will get 21 units square. So if you do it by integration, you also get 21 units square. It has to be the same thing. Then I'm going to integrate under the curve. Integrating under the curve, like I mentioned, in this situation means it stick on the y-axis. So I'm going to get the blue part. So the blue part will be the area under curve. So I'm going to use the y coordinate. So if I'm going to use the y coordinate, it will be a dy. I need to make x the subject. So I'm going to show you how to make x the subject. So for P and Q, you just do your own simultaneous equation. I won't be showing. So look at this. So I need to make x the subject. So I will be integrating the equation of the curve after I make x the subject. So do your normal integration. Okay, I'm assuming you don't make mistake in your integration. Okay, so you will get a 12 units. So the final shaded area, the shaded area which is originally here, will be the subtraction. The shaded area that eventually we want will be the trapezium minus the area under curve. So that is a subtraction. Okay, so if you look at example 6, okay, example 6, they asked us for coordinate first. They also gave us the intersection point. So for part A, they wanted the coordinate of A and B. So A is the y-intercept, B is the x-intercept. So you apply your x-intercept concept and y-intercept concept into the straight line equation. So you should be able to get the 2 coordinates. Okay, so the 2 coordinates that I gotten is 0 minus 2. B is actually 2 3. Okay, so in this case, then I got to plan for the shaded area. So if you look carefully, do you realize that the shaded area is under two lines? Some of the shaded area is under the blue straight line. Some of them is under the green curve. And the area is already stick on the y-axis. So I'm going to think about dotting over the intersection first. Dot over the intersection. And then you will see that you got two pieces of area. The blue one is a triangle. So that will be quite easy. The green one is area under curve. So I need to integrate. I need the y-intercept for the curve. So you still need to calculate the y-intercept of the curve by putting x equal to 0 into the curve equation. So you will get a 4 here. So for the green one is under the curve. So I need to do a definite integral. Okay, for the blue one, it is a nice triangle. I think it will be much easier if we do a half done base sum height. So how am I going to find the triangle? Half times, this one is 3 units. So base times height. Half times, oh, sorry, I wrote wrongly. This one is not total. It's a 1. So it's half times base times height, you get 3/2 units squared. Then the green part, you got no choice because it's under the curve. You got to integrate under the curve using the y coordinate. But because you are using the y coordinate, you actually got to manipulate the equation to make x the subject. So you cross multiply. Okay, remember your job is to make x the subject. Then you take square roots. Then you bring the 1 over. So all in all, if you try making x the subject, this is what you will have gotten. And for the area under graph, you are actually integrating this because you are using the y coordinate. So if you are doing it as the dy, the expression here must be in terms of y. That's why you got to make x the subject. Then you do your definite integral as per normal. You add a power, divide by new power. Okay, so usually I will punch calculator. I'll make the expression look nicer first before I do my definite integral. So some students, they don't have the habit of simplifying. They don't like to simplify and they put in the top minus bottom in a very difficult, how to say, in a very messy way, and they make careless mistake. So after this, I do my top minus bottom, I will get 4 minus 1. Sorry, 4 minus 3. So the green part is only 1 unit square. So the green part is 1 unit square. The blue part is 1.5. So the total shaded area, will just be adding the blue triangle and the area under graph. Okay, so these 3 examples illustrate when do you add, when do you subtract, and the idea about making x the subject. Because you are using y coordinate, that's why it's a dy. So the expression got to be in terms of y. And how do you tell negative, positive? So, okay, that will be a horizontal area when you are using y coordinate. Okay, so in an exam, you may, I will say that in the exam, right, most of the time, you are using the vertical area. Not so frequent that you'll be using the horizontal, but you still need to know. Sometimes you have no choice. But I will say 90% of the time you are using the vertical area.